Good morning, namaskar, millennium to power millennium. Good morning to everybody. Namaskar, this is Engineer Suraj Singh speaking from Bharat, India on this day, March 20, 2022, Sunday, 3:45 am. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 20 मार्च 2022 रविवार सुबह के 3:46। Back to you with series of talk, continuation of series of talk, quality and coordination, quality coordination, engineering projects works, reliable engineers, communication, concrete civil engineering, works contracts, safety health environment, designs, construction methods, claims organizations, works quality. You can see my email ID as suraj_engineer@yahoo.co.uk, and my title is Chartered Engineer India, International Professional Engineer India, and this is my certification. This is another certification, and here is another certification of fellow, and this is one file along with other file that I am going to share with you and explain. I close this certificate and I close this certificate as well for time being, and here is quality file. Here is quality file and this is coordination file. Both files shall be read together, and also there is another file that I'll discuss with you, I'll share with you, and that is here concrete specifications is coming to open. That is regarding concrete specifications, and I am referring to Japan. GSC guidelines for concrete, standard specification for concrete structures. It's old one, no problem. Something is better than nothing, and that's materials and construction. So my dear friends, as you may say, I always talk of this because I consider quality and coordination is very important in profession, and particularly in a profession where a lot of work is done in addition to whatever should be done. Engineering profession, and particularly civil engineering, which includes civil design engineering and civil construction engineering, and also which includes many other fields or overlapping, including mechanical engineering, electrical engineering, or architectural engineering, or you can say soil engineering, many other subjects in details, where quality criteria and coordination must be considered very significant. And if these are not considered significant, there shall be many losses on works. Losses means quality losses, and coordination means you have to understand, engineer has to take care of each and every aspect of these requirements. If I miss coordination which is required between some problem we have to solve. Every issue in engineering is related to coordination. If there is one point missing, for example, there remains one point missing. Another point is also missed, and then in following that another one is also missed. It's sequence of misorganization in that case. If we miss some point and we don't take care of that, it goes on augmenting and goes on making mistakes. And that's the reason when we start some work, we should actually foresee all problems that one is expected to see. We should know what may happen if I don't consider this point. When we plan something to construct, we arrange materials, we make list of materials for every activity, and there may be many hundreds activity on a building or on some structures. For every activity, there may be requirements of list of materials. We have to draw list of materials for a product, otherwise we do not know. For drawing list of materials, we should know how work shall be conducted. What is material requirement? How many human resources, persons will be required? And what technology we have to use, or what details we have to use. If technology is required, technology, which means how to do that work, and if reference is required, I mean to say available documents, and what machine we need, we have to know all these for every activity. It's not that easy as we think. Of course, those who are experienced, for them it doesn't cause a big problem. But if you ask some fresh person, go and do it, that fresh person will have to work on every such listing, and how many days before you require that. That is also an important point, because you cannot store some machine for more than required time. You cannot use people for more than required time. People means our workers. That's why I say coordination. This is also a part of coordination, that I have to understand what mechanism, what way I have to work on this area. That's also very important point. Quality and coordination are automatically imported when we do some work. And if we don't import them, then we export our presence. I can say our presence becomes negligible. There's no function left if I am present on work and I don't know what to do. If I cannot coordinate, if I cannot communicate, if I cannot intermingle, if I cannot understand drawings, if I do not know what are specifications and how to do this, and what does it mean I am present here? What does it mean? What does it indicate? Nothing. Means physically maybe I am present there as a competent person, but practically I don't have any competency degree, and that's very important point. So quality and coordination is therefore very important from practical viewpoint, and it's also true that no university, no institution can teach you about quality. They may tell you that this quality is there, this is that is. Superficially they may tell something, but as far as coordination is concerned and real quality is concerned, nobody will tell anything. Those who write books, they are authors, and generally they write books for text purpose, for syllabus purpose, syllabus of degree or post graduation or doctorate, whatever is they are limited to that point, not practical viewpoint. And engineering means it should be oriented on practice. Engineering education and engineering practice are different. Engineering education is very small part of engineering, while engineering actual experience, practice is long duration, in which our theories are implemented, theories are verified, practical work is done, and works are verified that what we thought of, it has been done in 100% cases. And if we do not do why it could not be done, then investigation is conducted and weaknesses are brought into that. Oh, this was our mistake, this is a lesson learned, we are learning this, next time we do this, we have to take care of that. And that becomes a part of quality criteria, as well as method statement. You can say experience-based learning. And experience-based learning continues for whole life. After passing 4 or 5 years syllabus, you work for 20, 30 years. This means many degrees you have passed. Every project is considered practically equal to degree, and that is why experience is given more weightage in engineering. How much experience you have in addition to your basic qualification, because if you are an educated and qualified person, you can learn best experience, better experience, and you can lead yourself, you can lead others. And what is required is leadership in field, leadership in designs, and leadership in construction, and leadership in quality, leadership in coordination. Coordination is also a leadership, because you should know all aspects of job. You should know not only your discipline but also disciplines of others who come into your contact, who shall come into your contact. For sure they will come into your contact, and you have to solve problems which are conflicted, which are unclear. We have to solve that. And that's why we can say when we have to do some project, it's not easy to say that it shall be done smoothly. Yes, design part is different. Even though in designs coordination is required, technical engineering coordination, requirements coordination, market coordination. If real designer means that real designer knows about market, real designer must know about what materials could be available, what materials should suit this, and whatever goal of this project that we want to do. All these requirements are must. It's not simply use of software and doing some calculations. That's one part of design. Another part is knowing everything about this project. What is purpose of this project? What is scope of this project? And what materials we use in this project? And how that material shall be utilized by those people who work on sites or in manufacturing. That must be known to everyone. If they don't realize this, means your design may not result in good buildability or constructability. And buildability and constructability are points of control where we can say this project would move smoothly or this project would cause obstructions. These points we have to understand. Means we have to keep our eyes open, our minds open while doing work. That's very important. So we can say quality and coordination is one part of life of an engineer, civil engineer at least, because we don't get everything ready-made. In civil engineering, that is a big problem, that you have to manufacture concrete, you have to manufacture mortar, manufacture or produce the same thing. When I'm saying manufacture, actually it is production or mixing of concrete and mixing of mortar, or you can say mixing of many different types of concrete, and fabrication of shutters on site, and cutting and fabrication of steel reinforcement, and of course everything is done, curing is done on site, de-shuttering or removal of shuttering is done on site. Means plastering is done on site, flooring is done on site, walling is done on site, roofing is done on site. You can see you may not get comprehensive built-up material, so you just bring and install. It's not like that. There is no activity in construction engineering. Generally 95% civil engineering activities have to be produced on sites. Only some materials are available. For example, bricks are available, but concrete is not available. Concrete either is ready mixed or we have to produce on site. It's one or both. Same way tiles are available. How to fix them is not available. You have to fix yourself. All materials are available in parts only. Otherwise, you have to do it. That's why civil engineering, construction engineering activity is a little different if you compare it to other engineering courses or programs. If you take, for example, HVAC engineering in buildings, HVAC machines are available. You have to just do ducting work. That's important. Fabrication of ducts and fixing of ducts, and that's important. In shop drawing of HVAC engineering, same electrical engineering. You have PVC conduits available, you have switchboards available, you have sockets available. You have to assemble them on site. And moreover, electrical engineering and mechanical engineering, of course, many other plumbing, for example, plumbing and sanitary engineering, environment engineering, security engineering. Means so many engineerings are there which are not directly done on sun, which are not done directly under sun or under adverse weather conditions. It is beauty of civil engineering that we work with nature, in nature, under skies. We start working under skies, and we bring other peoples to sit and sleep under roof. That is the difference part. This is the beauty of this engineering, that we provide shelter to everybody. Our workers shed their sweat and blood for those who would enjoy that structure. So we can do service to humanity, you can say indirectly. Humanity, of course, you can say it's not free of cost. I'm not talking of cost because cost is cost. But state of mind and state of conscious that civil engineer and its workers contribute to society all over the world. Even though mechanized work is used, concrete is by pumping, but concrete is concrete. It's method, and methods are important, and that's why I say what method we have to do, how to operate this activity, how to do this activity, what shall happen. If that is replaced by that material, you can say selection of material and training of people, and you can say selection of material, training of people, and taking an election of time which when I do this job. You have to understand weather conditions, you have to understand what is required, how temperature affects concrete, how addition of water affects concrete, and how workmanship affects concrete, how slump affects concrete, how people have to do it, and what's timing required for this. Means all these points we have to keep in mind like a surgeon. So we have to keep everything in mind, and if we don't, there is no support from time. Means if you start something, for example, I start concrete of a big slab, means it has to complete, otherwise it shall be a problem. We have to complete also irrespective of gap. Suppose sometimes we have 24 hours concrete, sometimes 48 hours concrete. So big raft will be 3 days. And I still remember one time when it was a raft constructed continuously for 7 days. This is different kind of world. Means those who do not know, I'm just trying to tell them it's different world. Don't underestimate it. Just because you may not get good package in construction engineering, because everybody, people don't respect civil engineering from package viewpoint. That's one problem. That's why even if people are attracted to civil engineering, they leave this field and go to some other field, for example, IT or management. And that's where we can say education is lost. If an engineer who has passed engineering degree or a post-graduation, and after that you leave that field and go to some other field, it's a sheer loss of your talent. Your talent, you try to measure in terms of package, but package is not answer for everything. Okay, you who are getting good package, you can enjoy your life, but at what cost? At cost of others who can't enjoy your life because you are lost. You do not contribute to society from engineering viewpoint. That's point I'm trying to stress. And this is commercial, you can say planning. This is business planning. People want to abuse those people who know mathematics, because civil engineers are very good in mathematics. Everybody knows civil engineers are good in mathematics, they are good in drawings, they are good in analysis, they are good in estimation, and they are good in many other designs, for example, site, for example. They can write, they can calculate. So they are used in management, they are used in IT. With some special training, they can continue with full force, and that's potential is required. And this is the reason I say now we have to be very careful. Yes, money is important. I'm not saying money is important, but development of world is also important. You think of if every civil engineer goes to those fields who will work for civil engineers. That's the point, because civil engineering or construction engineering requires sacrifice. The criteria of sacrifice is very important. Sacrifice that you have to leave your family, and you may. I have seen many civil engineers like me who don't have the endowment. No nuclear family is nothing, because your whole life you have worked in desert or in forest on projects. Who shall go there to live with you? That's one point. Means people like to enjoy. And if you don't provide entertainment to your wife, don't give time to her, you can't give all time because you are busy. At that point, you can say you can't move in unison or in, you can say, harmonious style or harmonious standard with your family. And that point is a negative one as far as social development is concerned, society is concerned, personal comforts are concerned, family building is concerned. This is my, it's a problem with every civil engineer who are, I'm not saying about designs people have a normal life. But those people who work in deserts under sun and who don't have sometimes even any facility with them for many months until that site is stabilized or site is mobilized, projects is mobilized, and I have still experienced that one. I still experienced in Libya, I experienced in many countries when there was no facility on site, and we used to take some bottled water and go to field early morning. And that's what I'm saying. We have to be a little concernable. We should not hide facts, and facts should be known to every boy and girl who intends to pass or intends to enter the field of civil engineering. Don't enter the field of civil engineering if you cannot do all this, if you cannot sacrifice, if you can't digest sun, if you can't stand for hours, and if sometimes you don't have any facility in field and you can manage and organize, It's not easy. Means everybody, people want to use air conditioning all the time. They want to enjoy cars, and they can't stand this weakness of youth today. Means everybody wants to control world through computer, but computer is not end of world. End of world is humanity. If my mind is not now, if I use computer all the time, if you don't know what's table of 2 or 3, I don't know how to calculate, I don't know what is how to mix, how to sum and how to deduct, or how to multiply and to divide, or how to square root and to cube root. If I forget all this, I don't remember anything. My mind remains inactive because of non-use and non-practice of mathematics or arithmetic. There was a time when I used to practice a lot of mathematics and writing and reading. People used to sit long time or borrow books from library and read that book. That practice is dead. If people say everything is available, every information is available on internet, I agree with that. Every information is available, but you have to sit on that information. You have to find that information. You have to understand which information is valid for you, which is not valid for you. And you have to read that for that purpose, and that reading is important. But who has time to see all this? It's very, I don't see many people who even browse internet, search some item and read them. They just try to get information and share without any analysis, and that's the point where weakness lies in. So in my talk I say quality coordination, this is a very important point, and then we talk of projects where engineers should be reliable. And that's what I'm talking of, reliability of engineers. If engineer is not reliable, there is no meaning at all. One has to be reliable, and that's the point where we have to think of reliability of engineers. If one is not reliable, means there's a problem. You cannot do reliable work. If engineer is not reliable, engineer cannot do reliable work. That point is very important. We have to concern it. We have to think of it. We have to deliberate on this issue from human resources viewpoint. What sort of engineer we are? Are we engineers for sake of engineering? We have to make this world better. That's the point we have to understand very well. And I say for our country, Bharat, India, we have to agree and we have to establish, and we should not believe in any concession. We have to think of, and we have to do, we have to produce works. Quality cannot be compromised thinking that way. If we compromise quality at all time, then we compromise engineering, because my product as civil engineer has to live for 50 to 100 or to 150 years, and products of other engineers cannot stay that long. No machine can stay for more than 5 years perfectly. You can say 5 years, 10 years. No electronic gadget can work more than 1 year or 2 years or 3 years very perfectly. You buy anything electronic item, it shall not work perfectly after a couple of months, a couple 1 year or 2 years, and that's the difference. We can say if you compare among construction engineering or civil engineering and other branches of engineering. And that's why we have to be very serious about this, that we have to give product for whole life, lifelong product, and not only lifelong, generations lifelong. You use this product, your son or daughter shall use this product, and maybe that sons and daughters, further sons or grandsons may use that project. And that's why quality is very important from construction or civil engineering viewpoint. And not only in our country, everywhere, but in our country it's most important because we generally use natural materials. In other countries I have seen people use different kind of houses, adobe houses, or you can say wooden houses, or plywood houses, or some others say structural steel houses. Generally it's not true, but people use structural steel buildings also. So these are based on foundations, RCC foundation. Yet in our country we use RCC buildings, of course combination of RCC buildings and brick buildings, and that's very important where long-term effect is considered. I've seen buildings which have just been constructed 5-10 years back, and they're distressing now. They show signs of distress, and that should not happen. So we can say there's no excuse for concessions. No concessions can be given as far as quality is concerned, coordination is concerned. If you cannot coordinate, coordination requires concentration. If you cannot concentrate, how can you do a job? How can you do better job? You cannot even think of doing a job. So I say works quality cannot be compromised, and therefore we do not intend to compromise just in the name of fragile system. System is system, we agree with that. It may be ISO 9000, it is Sigma based or some other system. Systems are systems that we decide based on experience, and we decide based on nature of working. Everybody decided that. But is that enough? If you say my company, my organization has been working in compliance to this system, is that enough? But you are not having any strict control on quality. And if you don't have strict control on quality testing, quality checking, quality measurement, quality controls and all that, you cannot say you are doing right work. Okay, you satisfy system, but you are not satisfying requirements. That requirement is important. And compliance, you can say, it doesn't matter if quality is not achieved. I don't accept this fact. Quality system doesn't mean anything if your product doesn't conform to requirements or doesn't perform to intended quality. So you may say quality should continue even if there exists no system. System may fail, but quality control must work. But it doesn't happen currently to my experience. Maybe your experience is different. Maybe you don't want to realize this fact. But this is a fact. You take construction engineering, you take electronics engineering, and you take mechanical engineering, you take whatever product available in market, you shall be confused about this issue that every product has some defect. Packaging is very good, talks are very good, every customer care unit talks very well. It's very important. Your call is very important for us. There can be questions on this. Only these types of fashionable designs of conversation have been made, but quality is not cared for. And that's why it's my concern, real concern and preliminary consideration is, where does quality exist? Nowhere. Generally, answer is unsuccessful to find anywhere existence of quality, and that is unfortunate. Where does coordination exist? And my answer is unknown conduct. I cannot find it. Did you find, or can you find for deliberation? If you find, let me know. We will discuss on that. And this red line we have to resolve. And that's the issue. Can we bring working environment to quality and coordination requirements? We have to get this point into our clarification. Now we have another file, as I told you. We have here coordination engineering file. Coordination, as I'm talking about in quality talks, and coordination engineers, coordination engineering project public engineers are very important for everyone. For reliable quality engineering works deliveries, coordination engineering is a must. And here is some note on that, which every time we discuss, missing coordination means missing good engineering. Because if you miss one point in coordination, this means you miss something required for quality. You miss that parameter, which must have a certain point. Suppose I want to do concrete, I don't have information for temperature, what kind of temperature I have to maintain for concrete, and I don't care for that. I don't try to find that information because I don't know how to coordinate. Who has time for this? Okay, fine, weather is good, do it. And that point is done. We don't care what's minimum, what's maximum temperature, what's curing temperature, what's concrete temperature, hardened concrete temperature, and what's temperature inside of some block of concrete, and what's temperature outside of that, what is thermal gradient of that concrete from time to time. All these points, which are part of technical coordination and engineering coordination, are missed. We say, okay, we have done it, it's very solid, but it's very solid, and maybe there are minor cracks we don't care for, but it should be careful. Likewise, I say, everything is not so easy as we think. We have to think from every angle, from every aspect. And that aspect is what we call communication support for reliable. Projects are not all the time you can say everything is fine, we have done it, we have done it, we have done it. We may say we have done it, but we did not do it, and that's point where it's important. So say, if you just see, I'm just trying to my notes that are given on this card. Yes, that's why it's coordination engineering must know every project, and that is already point every time I refer to. This time also I want to spend some time on this coordination. Designs, constructions and controls are very absolutely interrelated, of course. Designs means what to construct, and construct means what controls we have on that. For achieving from successful start to completion of a project, which all must be applicable throughout project stages with all works be smoothly affected. These sections or stages are initial conceptual designs, designing for works execution purposes, procedure, implementations, about how to chart out construction of designed project works, project construction works, currency decision and works carrying out, testing, completion and commissioning and launching use of project. When project title terminates, renaming that title, operation or occupation on a place of project. Designs may be considered designs designs may be considered oversafe or optimal, but real construction involves actual expenses, contract time, financial liabilities, and buildings' professional reputation, which all must be cared for sincerely by both stakeholders as such, owner and engineer at time of designs. A well-designated project could be jeopardized during construction itself. From budgetary viewpoint, should it not be given due required controls application properly. Without organizing with full intensities, keeping eagle eyes on project and construction controls, no project can be delivered in time and fixed budget. First act of project leader therefore should be and must be to get into allotted budget and then to move project within its defined ambit. One should remember that once money is lost, it cannot come back. No possibility exists to retrieve that lost money back. Analysis tool can be required to operate with complete dedication to carry out or conduct controls. All required sections related to activities import total dedication from quality input within such disciplines in actions as well as in works. Whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review and to ensure constructability issues. It can be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions, workable, consistent and competent solutions to achieve successful performance of every activity to be conducted to avoid possible delays. My point of view is we have to keep in mind always activity in construction engineering, whatever we do shall become a product for many, many decades to come. Do not think that it's going to be used for a couple of years like other equipment are. Your building, your structure is an equipment to be used for many, many decades to come. Just think that it's also an equipment, you can say, because we equip many materials there. Sand is equipped, sand, aggregate, fine coarse, cement or cementing materials, or you may say whatever else we use there is produced for many decades. It shall serve for many, many decades. Just like you can say rocks serve this earth for many decades. Earth itself has been there for since times we do not know. In the same way, today we produce some structure and it can work for many hundred years. Nobody knows. That's point we say. So it will exhibit signs of distress but continue, and there can be crashes also. So those considerations must be taken care of, and that point is very, very important, and every engineer is supposed to think of that. that construction engineering is not like other engineering. It's different because it involves life, our lives. It involves, we cannot risk our lives just because by doing good or bad. Which work? Bad work. We cannot do bad work. That bad work or substandard work, or you can say negligent activity based work, doesn't mean anything in construction. So we have to keep this point in mind and understand this, what we are saying. Last time we were talking about this file, and this time also we are serious about this file. It is now, I'm talking about this file, which is Japanese specification. Yesterday we were somewhere on 65 page. Correct. Powdery material. In this diagram we discussed the powdery material, pointed cement, and also slump fit, some consistency and workability we discussed in this case. Pumpability, what is pumpability? Was placing height and compaction height. We discussed durability. Yes, that durability we can stop. Let's start from here itself. Durability in itself is a very important point. It's very important in a sense in soil engineering. We have to take care of this. We have to, whatever product, whatever work we have to do, we have to keep in mind durability of that product, because durability means long distance travel in safe mode. You got my point. Itself is durability. Durability means external actions, according to this book, external actions which adversely affect the durability of concrete include freezing and thawing actions. For concrete means there's freezing act, and then there is a melting act or thawing act. This impact on durability properties of concrete, and because due to attacks by chemical substances and rubbing action. Furthermore, when materials of poor quality are included or used, long-term stability of concrete is deteriorated. In case of members of reinforced concrete and pre-stressed concrete, corrosion of embedded steel progresses and respective durability is damaged. If 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 concrete is neutralized or chloride is accumulated beyond a certain limit in members, then durability is attacked, it is impacted, or is challenged. So what we have to say, just this very small definition given, I'm not happy with that. There's really more, because strength is an issue, then deflection is also an issue, overstress is an issue, then cracking is an issue, heat is an issue. There are so many issues, valves, so whatever it is. We can add on to that an alkali aggregate reaction, then freeze thaw resistance, then crack resistance. Let's see what it says. Alkali aggregate reaction. Alkali aggregate reaction is classified broadly into alkali silica reaction and alkali carbonate reaction, depending on kind of minerals or substance which reacts with alkali. Most of reported cases of alkali aggregate reaction in Japan are alkali silica reaction. When alkali silica reaction occurs, cracks develop in concrete. Alkali silica reaction, you know what is silica? It's a kind of sand. So alkali silica reaction occurs, cracks develop in concrete because the resulting alkali silica gel swells when absorbs water. Freeze thaw resistance, you know what is freezing of when it is snow falls, freezes, and then it evaporates, thaws when concrete and or aggregate particles when concrete and or aggregate particles containing water are frozen. Expansive pressure develops after freezing, Expansive pressure develops due to freezing of free water inside these materials. Freezing and thawing action induces slack or damage in structure of materials due to expansive pressure. Degree of damage increases with repetition of freezing and thawing actions. Degree of damage increases, and trained air in concrete plays a role of relieving expansive pressure during freezing of concrete. So that is entrained air. Entrained air in in concrete plays a role of relieving expensive pressure during freezing and concreting. It's very common sense. Crack resistance. Crack resistance, it is very difficult to avoid cracking, but controlling number of cracks and crack width is comparatively simple. Controlling crack is very important as long as durability of concrete water tightness, and its appearance are concerned. Cracks may be induced by many causes, but it's possible to improve crack resistance by properly selecting materials, mixed proportions, construction method. In addition, appropriate design of concrete structure is also very effective in crack controlling. Inspection is carried out on qualities of materials, concrete construction process, and constructed structure. That inspection is carried out on qualities of materials, concrete construction process, and constructed structure using various inspection systems. Generally, inspection of material and product is carried out by purchaser. In many cases, a structure owner just confirms inspecting results based on inspecting records. Afterwards, in case of ready-mix concrete, constructor usually carries out inspection because they purchase materials. However, designated inspector often carries out inspection when ready-mix concrete is used. Inspections during construction or at completion are commonly carried out by structure owner. Now we talk of something technical, also very technical, moist curing, and it's to ensure you can say necessary amount of water for hydration of cement in concrete, since it's not sufficient just by preventing evaporation of water from placed concrete. Curing method is also effective in preventing cracking due to drying shrinkage during initial hardening stage. Temperature control curing. Curing method is to control temperature in each part of concrete to facilitate normal hardening process and to avoid cracking after hardening, as well as and development of excessive internal stress. In utilizing this curing method, it is necessary to take into account both size of members and effect of construction condition. Accelerated curing. Some curing methods to accelerate hardening rate of concrete, such as steam curing, autoclave curing, hot water curing, electrical curing, infrared curing, and high frequency curing. However, in general, steam curing is widely used. Quality of concrete. Concrete used shall be one that has consistent quality and workability. Consistent quality and workability. It's still 56%, all right. Concrete used or included shall be one that has consistent quality and workability, suitable for construction tasks to be performed, and after hardening has required properties such as strength, durability, water tightness, and cracking resistance. Durability, strength is of course must be, how durable it is, and what's water tightness status, and cracking resistance. In order to create a concrete, in order to create a concrete structure that has required performance attributes, it's necessary to use concrete that provides structure with those performance attributes and making proper concreting possible. In accordance with this principle, this chapter specifies basic quality requirements for concrete. Basic quality requirements for concrete specified in this chapter are qualitative consistency, workability, strength, durability, water tightness, and cracking resistance. So what is it says is sequence. If you see, qualitative consistency means what is level of quality, how can you justify quality consistency, then workability, how to work upon this concrete supplied or concrete mixed, workability, then its strength, how much strength does this concrete achieve, and then durability, water tightness, and cracking resistance. It's a strength. I say qualitative consistency. You know meaning of that now. Qualitative consistency means highly variable quality of concrete. Highly variable quality of concrete supplied for construction. Highly variable quality of concrete supplied for construction of a structure not only increases possibility of occurrence of defects during construction, but also necessitates use of large factor of safety in mixed design. To achieve required strength, making construction project uneconomical, inconsistent quality of concrete may also degrade durability. Inconsistent quality of concrete may also degrade durability, cracking resistance, and appearance. When manufacturing concrete, therefore, it's very important to secure a supply of concrete of stable quality. To do that, it's important to perform thorough material quality control and concrete manufacturing control. Workability. We do work of concrete, means we have to deal concrete. We should have comfortable position is doing that, ease of doing, you can say. Workability is in order to carry out construction, work efficiently, and create a concrete structure with as few defects as possible. Concrete use shall have type of workability suitable for such tasks as hauling. Hauling is first, then placing, compacting, and finishing. In other words, workability attributes such as filling or pouring ability, by which to completely cast formwork, including regions around reinforcing steel and corners. Pump ability necessary for one on-site pumping and appropriate setting properties are very important in order to carry out construction appropriately and efficiently. and construct a concrete structure with as few defects as possible. Strength. If concrete structure is to maintain required strength, required safety and serviceability. Again, if a concrete structure is to maintain required safety and serviceability during its service period, concrete used shall have strength. Assume that design stays. That is, design strength, initial strength development are an important factor affecting speed of construction. Now durability. This is very small explanation, strength a lot should be. Durability. If concrete structure is to maintain required safety and serviceability during its service period, concrete included shall have required durability as well as design strength. In order for reinforcing steel placed in concrete structure to perform required functions over a long period of time, concrete needs be capable of effectively protecting reinforcement steel from corrosion. Durability attributes required for concrete can be classified into physical action such as freeze-thaw action, chemical action caused by sulfates, acids, etc., durability of concrete itself against its own deterioration attributable to quality of materials used such as alkali silica reaction, and ability to protect steel from action of chloride, ions, carbon dioxide, etc. that accelerates steel corrosion. By infiltrating concrete. It is therefore necessary to take these into consideration on as required basis. Water tightness. Water tightness is a quality attribute. Let me see how much it is now. 49-49%. Just 5 minutes oil. Water tightness. Water tightness is a quality attribute indicating resistance to water or moisture permeability. Concrete structures that require water tightness are structures whose safety, durability, functionality, safety, durability, functionality, maintenance, appearance, etc. are affected by water permeability. Examples are storage facilities, underground structures, hydraulic structures, water storage tanks, drinking water and sewer facilities and tunnels. Leaching of calcium. Leaching of calcium from concrete might also cause performance degradation. Leaching of calcium from concrete might also cause performance degradation of structures, even over a long period of time. Thus, water tightness is a quality attribute that needs to be taken into account when considering structures that come in contact with water. Cracking resistance. Cracking resistance. Excessive cracking in concrete structure not only has adverse effects on durability and watertightness but also degrades appearance of structure. It's very important, therefore, to use concrete that is highly resistant to cracking. There may be cases, there may be cases depending on type of structure or member where quality attributes of concrete other than those described in this chapter are required. In such cases, quality of concrete shall be determined so that required performance of structure can be achieved. Now, qualitative consistency